And we're live. So last time we were going through IBM's Python for Data Science, AI, and Development course. And within that, we just finished watching sets, and we were getting started with our um, assignment here. Let's launch that. So this is hands-on practice for Python, so sets in Python. It looks like it'll take 20 minutes. So let's go through this. Sets, set content. A set is a unique collection of objects in Python. You can denote a set with a pair of curly brackets, and Python will automatically remove duplicate items within that set. Sets is a good way, again, as the video alluded to, the best way to think about sets is with diagrams. Where are they? Yeah, right, like awesome. A set is a unique collection of objects in Python which is not repeated. So you can denote a set with a pair of curly brackets as shown here. Set 1 is defined as multiple strings, a series of strings, and Python will automatically remove the duplicate items. So the process of mapping is illustrated in the figure here, where we can see that multiple instances of the word rock become a single instance. Then we have each unique instance in the set. You can also create this set as so as we can see, it creates reduces all the values to just unique values. And you can also create a set from a list as shown here. So we are creating a list called album list, and we have multiple items in this list, including the name, the album name, artist name, or album name, year, I think the entire length here, the genre, and some other details. So then what we can do is we can use the set function to define or rather typecast the list into a set. And once we print album set, we essentially get a set from that list. Now let us create a set of genres. Now music genres is defined as a set where within the set function we are creating a list where the list has multiple genre names repeated, and then when we print music genres we clearly see that it's all unique values. Now let's go through set operations. So as we go over set operations, we can understand that we are using set operations to perform changes on a set. Consider the set A. So set A has, again, the way we create a set is A equals set function and then a list inside, or you can just create curly braces and open curly braces, write a list of items and close the curly braces. So again, as we go over the set operations, we define set A as with these three unique strings, and then we try and print A. So we see them back. We can add elements to a set using the add method. So to add, we say a dot add. So set a dot using the method add. We are going to add nsync to A, and then here we see if we add the same element twice, nothing will happen as there can be no duplicates in a set. So as we can see, nothing will happen. We can use the a.remove method, sort of set.remove method to remove a string. We can verify if an element is in the set using the in command. So we can check whether that is true or false. Let's look at set logic operations. Remember that with sets, you can check the difference between sets as well as the symmetric difference, intersection, and union. Let's consider the following two sets. So set 1 is has album list 1 and set 2 is album list 2. The way we are creating that is shown here. Let's execute that. Next, let's print the two sets. So as we print the two sets, we clearly see that they are repeated here in sets, as both sets contain ACDC and back in black. We represent these two common elements with the intersection of these two circles, right? Clearly, these two are common across both sets. So we can find the intersect of the two using the AND command. So let's find the intersection. Intersection we're defining as album set A and album set 2, which gives us ACDC and back in black. You can also find all the elements that are contained in album set 1 using the difference method. So we want only the things in album set 1 and not anything that belongs to album set 2. We are going to use album set 1 dot difference and then pass the parameter to the function difference or the method difference as album set 2, so that we are subtracting album set 2 from album set 1, and we get Thriller. You only need to consider elements in album set 1. All the elements in album set 2, including the intersection, are not included, clearly. Elements in album set 2 but not in album set 1 is given by album set 2 dot difference, and we pass album set 1. So we are subtracting album set 1 from album set 2, and there we get the difference. You can also find the intersection of album list 1 and album list 2 using the intersection method. So we just want to know what is common between these two sets. We can use the intersection method. So album set 1 dot intersection album set 2 corresponds to these two circles, and I presume album set 2 dot intersection two. Let's see, this gives us ACDC and back in black. Let's see what the other one gives us. Album set 2 intersection album set 1. Yeah, exactly the same. So yeah, that was my mistake. I was checking what's a intersection of album set 2 with intersection of album set 2, which was wrong, which is why it gave me all the three values. But yeah, now that we fixed it, both of these are the same thing. So essentially, whether it is the intersection of set 1 by 2 or 2 by 1, it's the same thing. So you get the intersection of the two. So this corresponds to the intersection of the two circles. The union corresponds to all the elements in both sets, which is represented by coloring both the circles. So all the elements in both the sets. The union is given by the function. To find the union of two sets, we would say album set 1 union album set 2, which gives us this. And I presume it would be the same the other way around. Album set 2 and album set 1 should be the same. Yes, it is the same. And you can check if a set is a superset or a subset of another set, respectively, like this. So to check if set is a superset, we write set album set 1 dot superset is superset of album set 2. So we're trying to figure out if the set album set 1 is a superset of album set 2. False. Is album set 2 a subset of album set 1? That's also false. Here is an example where is subset and is superset return true. So check if in this set back in black and this is subset album set 1. Yes, so this would be a subset of album set 1, and this would be a superset. Is superset. Check if album set 1 dot superset set 1 dot is superset. Okay, yeah, makes sense. So here we have created a set specifically. Yeah, but why did we have to create a set here and not here? That's a little confusing. Okay, if someone knows, please explain it to me in the comments, because I'm not sure why. Or maybe these are both methods of expressing a superset. So I'm going to check into this. Quiz on sets. Convert the list rap house electronic music rap to a set. Write your code below. Okay, let's execute on this. Convert the list. If I consider the list A equals this and set B equals this. Excuse me. Excuse me. Oh, sorry. False. So clearly set would be different because each instance would be unique, and you'll only be left with 1 and 2 where this has all its elements. it retains all its elements. So now let's create a new set, album set 3, that is the union of album set 1 and 2. Yeah, so album set 1. Isn't that what it is? Union, yes, that is what it is. Yep. Album set 3 equals album set 1 union. Yeah, and we didn't print album set 3, but we can print that. There we go. So we get a union of both, and then let's find out if album set 1 is a subset of album set 3. Set album set 1 is subset album set 3, and that is correct. Album 1 is a subset of album set 3. Oh, we can, okay, so both works. Okay, so let's also add this. So now I get it. My question is answered essentially from earlier. Album set 1 dot is subset a album set 3, and then true. Okay, got it. So both work. And the last exercise, oh, this was the last exercise, so we finished this shit. Okay, awesome. See you in the next one. Or I guess we'll keep continuing with this. So let's go through the quiz. Consider the following. Get following set where there's what will result when you create the set. There'll be only one element left, which is A. What method do you use to add an element to a set? Add, the add element thing. Add method. What is the result of the following operation? Set A, B is a set which contains A and B, and a set which contains A. So what are the things that are in both things, which would be left with A? And I think that's my submission. I think if they don't give me 100%, then they're wrong. Yeah, exactly. So here's the summary. We often use tuples to group related data together. Tuples refer to the ordered and immutable collection of elements. Tuples are usually written as comma separated elements in parentheses. You can include strings, integers, floats in tuples and access them using both positive and negative indices. You can perform operations such as combining, concatenating, and slicing on tuples. Tuples are immutable. So you need to create a new tuple to manipulate it. Tuple term nesting. Tuples term nesting can include other tuples of complex data types. You can add elements in a nested tuple through indexing. Lists in Python contain ordered collections of items that can hold elements of different types and are mutable, allowing for versatile data storage and manipulation. A list is an ordered sequence represented with square brackets. Lists possess mutability, rendering them akin to tuples. A list can contain strings, integers, and floats. You can nest lists within it. So you can nest lists within lists. You can access each element in a list using both positive and negative indexing. Concatenating or appending a list will result in the modification of the same list. You can perform operations such as adding, deleting, splitting, and so forth on a list. You can separate elements in a list using delimiters. Aliasing occurs when multiple names refer to the same object. You can also clone a list to create another list. Dictionaries in Python are key value pairs that provide a flexible way to store and retrieve data based on unique keys. Dictionaries consist of keys and values, both composed of string elements. You denote dictionaries using curly brackets. The keys necessitate immutability and uniqueness. The values may be either immutable or mutable, and they allow duplicates. You separate each key value pair with a comma, and you can use color highlights to make the key more visible. You can assign dictionaries to a variable. You can use the key as an argument to retrieve the corresponding value. You can make additions and deletions to dictionaries. You can perform an operation on a dictionary to check the key, which results in true or false output. You can apply methods to obtain a list of keys and values in a dictionary. Sets in Python are a collection of unique elements useful for tasks such as removing duplicates and performing set operations like union and intersection. Sets lack order. Curly brackets are helpful when defining elements of a set. Sets do not contain duplicate items. A list passed through the set function generates a set containing unique elements. You use the set operations to perform actions such as adding, removing, and verifying elements in a set. You can combine sets using the ampersand, which is the AND operator, to obtain the common elements from both sets. You can use the union function to combine two sets, including both the common and unique elements from both sets. The subset method is used to determine if two or more sets are subsets or supersets. Yeah, I'll put these in a repo later for everybody to consume and then post it there. So, yeah, catch up with me soon. And let's save this as a PDF. So, this can also be available for Okay. Okay, this is done. So we're going to close both these, then mark as completed, and move on to the next item. Okay, so let's do the quiz for Python for data structures. Examine the tuple A equals, this is a tuple, and this is a list, which involves a tuple and a list. What is the outcome of the following operation? A1, so we get the list. Consider the tuple A, where there's another tuple in it, then two lists, contains a tuple and two lists. What is the result of the following operation? A2, 0, 1, 2, so we get 4. If L equals the list of C and D, then the output of the statement will append A and B will C, D, A, B. Yes, that is what we will get. Append. Append will give us this. Yes, append will give us this. Extend will give us this. Consider the following list. A equals hard rock 10, 1.2. What will the list A contain after running around till A0? So 10 and 1.2. If A is a list, what does the following syntax do? Uh, list B, yeah, that's exactly what happens. What is the outcome of the following? Okay, let's just like run through the method of elimination. A is a list, and we are essentially typecasting B or assigning B to the list A with all of its elements from start to end. Now, essentially, that's what this is, but let's run through the other ones. List A gets converted to a set that is loaded to B. No, that's not what's happening. There's no curly braces. Creates a new reference variable B that points to a copy or clone of the original list A. No, that's not what's happening. Again, that's a different method. B gets transposed. If you remember it, drop it in the comments with the timestamp so people will know that you know. B gets a transposed form of the list A. We're not doing any transposition here, so no. So clearly, that's the answer. What is the outcome of the following? Length of the tuple which has these elements: 1, 2, 3, 4, 5. 5. Yeah, 5. Consider the following dictionary: the bodyguard, 1992, Saturday Night Fever, 1997. Select the keys. So these are the keys, and then these are the values, because each is a key value pair. The variable release year dict is a Python dictionary. What is the outcome of applying the following method? Values, we get the values. Retrieve the entire count, retrieve the values of the dictionary. Yes, we retrieve the values of the dictionary when we use dot values method. Consider the set v is equals this, and then what is the result of 1, 2, 3? What is the result of the following? A in set this true. Yeah, sorry about that. That was just something else, some meeting that I was supposed to be in, I guess. But I'm studying, so that's where you go. Awesome. So that was the last thing. A in A and B. Yeah, this is true, right? Like A is in A and B, so this is true. And there we go. Let's submit it. I think I should get 100. Because if I don't, I messed up. What are you talking about, bro? $90. Where did I go wrong? And you won't even tell me where I went wrong? That's not helpful for Sarah. If you guys see where I've gone wrong, please let me know. 0, 1. Yeah, this is correct. Then 0, 1, 2. So we get 4. Then yeah, so I was correct. So what's going on, man? Okay, so doesn't look like there's anything else here. I don't even know where I went effing wrong. You should be telling us where you went wrong, right? What's happening here, man? I should be getting 100%. Otherwise, you guys have something wrong with you. Exactly. I'm on fucking point. I don't know. Keys, right? Yeah, these are values. Keys, values. These are values. Yeah, exactly. I'm correct. Even here, bro. Like 1, 2, 3, 4, 5. Yeah, 5. So this is what's wrong. Okay. Okay. I guess that's what's wrong. Try again. Hopefully we get new questions, but 1. Okay, this was 2 0. Yeah. Okay. 2 0 1 2. So 4. The method append does to the following. Does the following adds. Consider the following list: A equals hard rock and 10.1 and 1.2. What will A contain after the following command is run? Delete A1. So this is 0, this is 1, so we remain with hard rock and 1.2. If A is a list, what does the following syntax do? Creates a new reference variable B that points to a copy or clone of the original list A. What is the result of the following? So I guess I need to learn more. Clearly this was wrong. If this is wrong, or rather if this is correct, then I was wrong earlier. What is the result of the following? Length of this contour 2 consists of the following. Select the keys. Keys, not values. Select keys. So these are the keys, these are the values, key value pairs. In the Python dictionary, what is the outcome of applying the following method? Getting the values, retrieve the values of the dictionary. Consider the set V, this 1, 2, 3. Outcome of 1 and 2, true. $100, bro, 100. Give me 100. What? Again? Okay, I gotta try again. This is pissing me off. Examine the tuple 0, 1, so we get 21, 22. And consider that contains a tuple on a list. What will follow? 2 is 4. If output of append AB would be CD, comma AB. List AB. Okay, consider the following list. Delete A1, 10. Hard rock 1.2. What does it's a transposed form of list A. Okay, so this is not correct. Okay, B gets a transpose. The syntax does not transpose the list; it creates a copy. Okay, It's a new variable b that points to a cone of upper limit. This is the correct interpretation. The slice notation creates a shallow copy of the list A, meaning that B will have the same elements as A, but they will be distinct lists in memory. List A gets converted to a set. This is not accurate. This is not correct. Okay. Length of this is 2. The bodyguard keys, key values, keys of the dictionary. Items method. Okay, yeah. mydic.items, dictionary.items. Set what is the result of we add 3 1 2 3 outcome of 1 in outcome of 2 is correct, true. Why are you not giving me 100%? Give me 100%. I'm gonna let this go. If it doesn't give me 100%, I'm just gonna pass. Okay, I give me 100% because that's what I deserve.
In this video, you will learn about conditions and branching. Operations compare some value or operand. Then, based on some condition, they produce a... You will learn about conditions and branching. Comparison operations compare some value or operand. Then, based on some condition, they produce a Boolean. Let's say we assign a value of a to 6. We can use the equality operator denoted with 2 equal signs to determine if 2 values are equal. In this case, if 7 is equal to 6. In this case, as 6 is not equal to 7, the result is false. If we performed an equality test for the value 6, the two values would be equal. As a result, we would get a true. Consider the following equality comparison operator. If the value of the left operand, in this case the variable, I, is greater than the value of the right operand, in this case 5, the condition becomes true, or else we get a false. Let's display some values for I on the left. Let's see the values greater than 5 in green and the rest in red. If we set I equal to 6, we see that 6 is larger than 5, and as a result, we get a true. We can also apply the same operations to floats. If we modify the operator as follows, if the left operand I is greater than or equal to the value of the right operand, in this case 5, then the condition becomes true. In this case, we include the value of 5 in the number line, and the color changes to green accordingly. If we set the value of I equal to 5, the operand will produce a true. If we set the value of I to 2, we would get a false because 2 is less than 5. We can change the inequality if the value of the left operand, in this case I, is less than the value of the right operand, in this case 6. Then condition becomes true. Again, we can represent this with a colored number line. The areas where the inequality is true are marked in green, and red where the inequality is false. If the value for I is set to 2, the result is a true, as 2 is less than 6. The inequality test uses an exclamation mark preceding the equal sign. If two operands are not equal, then the condition becomes true. We can use a number line. When the condition is true, the corresponding numbers are marked in green and red for where the condition is false. If we set I equal to 2, the operator is true as 2 is not equal to 6. We compare strings as well. Comparing AC/DC and Michael Jackson using the equality test, we get a false, as the strings are not the same. Using the inequality test, we get a true, as the strings are different. See the labs for more examples. Branching allows us to run different statements for a different input. It's helpful to think of an if statement as a locked room. If the statement is true, you can enter the room, and your program can run some predefined task. If the statement is false, your program will skip the task. For example, consider the blue rectangle representing an AC/DC concert. If the individual is 18 or older, they can enter the AC/DC concert. If they are under the age of 18, they cannot enter the concert. Individual proceeds to the concert. Their age is 17, therefore they are not granted access to the concert, and they must move on. If the individual is 19, the condition is true. They can enter the concert. Then they can move on. This is the syntax of the if statement from our previous example. We have the if statement. We have the expression that can be true or false. The brackets are not necessary. We have a colon. Within an indent, we have the expression that is run if the condition is true. The statements after the if statement will run regardless if the condition is true or false. For the case where the age is 17, we set the value of the variable age to 17. We check the if statement. The statement is false. Therefore, the program will not execute the statement to print, "You will enter." In this case, it will just print, "Move on." For the case where the age is 19, we set the value of the variable age to 19. We check the if statement. The statement is true. Therefore, the program will execute the statement to print, "You will enter." Then it will just print, "Move on." The else statement will run a different block of code if the same condition is false. Let's use the AC/DC concert analogy again. If the user is 17, they cannot go to the AC/DC concert, but they can go to the Meatloaf concert represented by the purple square. If the individual is 19, the condition is true. They can enter the AC/DC concert. Then they can move on as before. The syntax of the else statement is similar. We simply append the statement else. We then add the expression we would like to execute with an indent. For the case where the age is 17, we set the value of the variable age to 17. We check the if statement. The statement is false. Therefore, we progress to the else statement. We run the statement in the indent. This corresponds to the individual attending the Meatloaf concert. The program will then continue running. For the case where the age is 19, we set the value of the variable age to 19. We check the if statement. The statement is true, therefore the program will execute the statement to print "you will enter." The program skips the expressions in the else statement and continues to run the rest of the expressions. The elif statement, short for else if, allows us to check additional conditions if the preceding condition is false. If the condition is true, the alternate expressions will be run. Consider the concert example. If the individual is 18, they will go to the Pink Floyd concert instead of attending the AC/DC or Meatloaf concerts. The person of 18 years of age enters the area as they are not over 19 years of age. They cannot see AC/DC, but as they are 18 years, they attend Pink Floyd. After seeing Pink Floyd, they move on. The syntax of the elif statement is similar. We simply add the statement elif with the condition. We then add the expression we would like to execute if the statement is true, with an indent. Let's illustrate the code on the left. An 18-year-old enters. They are not older than 18 years of age, therefore the condition is false, so the condition of the elif statement is checked. The condition is true. So then we would print, "Go see Pink Floyd." Then we would move on, as before. If the variable age was 17, the statement "Go see Meatloaf" would print. Similarly, if the age was greater than 18, the statement "You will enter" would print. Check the labs for more examples. Now let's take a look at logic operators. Logic operations take Boolean values and produce different Boolean values. The first operation is the not operator. If the input is true, the result is a false. Similarly, if the input is false, the result is a true. Let A and B represent Boolean variables. Logic operations take Boolean values and produce different Boolean values. The first operation is the not operator. If the input is true, the result is a false. Similarly, if the input is false, the result is a true. Let A and B represent Boolean variables. The OR operator takes in the two values and produces a new Boolean value. We can use this table to represent the different values. The first column represents the possible values of A. The second column represents the possible values of B. The final column represents the result of applying the OR operation. We see the OR operator only produces a false if all the Boolean values are false. The following lines of code will print out. This album was made in the 70s or 90s, if the variable album year does not fall in the 80s. Let's see what happens when we set the album year to 1990. The colored number line is green when the condition is true, and red when the condition is false. In this case, the condition is false. Examining the second condition, we see that 1990 is greater than 1989, so the condition is true. We can verify by examining the corresponding second number line. In the final number line, the green region indicates where the area is true. This region corresponds to where at least one statement is true. We see that 1990 falls in the area. Therefore, we execute the statement. Let A and B represent Boolean variables. The AND operator takes in the two values and produces a new Boolean value. We can use this table to represent the different values. The first column represents the possible values of A. The second column represents the possible values of B. The final column represents the result of applying the AND operation. We see the AND operator only produces a true if all the Boolean values are true. The following lines of code will print out. This album was made in the 80s if the variable album year is between 1980 and 1989. Let's see what happens when we set the album year to 1983. As before, we can use the colored number line to examine where the condition is true. In this case, 1983 is larger than 1980, so the condition is true. Examining the second condition, we see that 1990 is greater than 1983, so this condition is also true. We can verify by examining the corresponding second number line. In the final number line, the green region indicates where the area is true. Similarly, this region corresponds to where both statements are true. We see that 1983 falls in the area. Therefore, we execute the statement. Branching allows us to run different statements for different inputs.
Alrighty, and then we'll go on to the hands-on lab for conditions and branching. Alrighty, so conditions and branching. We'll start with conditional statements and comparison operators. This is checking whether something is something's value is equivalent to one another. This is checking if it is not equal to one another, greater than, less than, greater than, equal to, less than, equal to. Let's assign a variable a to value of 5. Use the equality operator denoted with the 2 equal sign to determine if two values are equal. The case below compares the variable a with 6. So we're defining a as 5 and we're checking if a equals 6, and the result is obviously going to be false because 5 does not equal 6. Consider the following equality comparison operator. I is greater than 5. If the value of the left operand, in this case the variable I, is greater than the value of the right operand, in this case 5, then the statement is true. Otherwise the statement is false. If I is equal to 6 because 6 is larger than 5, the output is true. Yeah, true. I is set to 2, the argument will result in false. Yeah. Let's display some values for I in the figure. Set the values greater than 5 in red and the rest in greater than 5 in green and the rest in red. The green region represents where this condition is true and the red is where the statement is false. If the value of I is 2, we get false, as 2 falls in the red region, and is similarly, if the value of I is 6, we get true, as the condition falls in the green region. The inequality test uses an exclamation mark preceding the equal sign. If two operands are not equal, then the condition becomes true. For example, the following condition will produce true as long as the value of I is not equal to 6. So we get true. When I equals 6, the inequality expression produces false. In this scenario, it produces false. See the number line below where the condition is true, the corresponding numbers are marked in green, and for when the condition is false, corresponding number is marked in red. If we set I equal to 2, the operator is true since 2 is in the green region. If we set I to 6, we get false since condition falls in the red region. We can apply the same method on strings. For our example, we can use the equality operator on 2 different strings. As the strings are not equal, we get a false. So clearly this is not equal to this. We're checking, if they are, and those values, the values of those strings do not match, so we get a false. If we use an inequality operator, the output is going to be true though, as they're not equal. The inequality operation is also used to compare letters, words, symbols according to the ASCII value of letters. The decimal value shown in the following table represents the order of the character. So these are the ASCII values for each alphabet in capsed form. So for example, the ASCII code for exclamation is 33, while the ASCII code for plus is 43, and therefore plus is larger than exclamation, as 43 is greater than 33. Similarly, from the table above, we see that the value for A is 65 and the value for B is 66. Therefore, B is greater than A. It's true. When there are multiple letters, the first letter takes precedence in ordering. So BA, AB would make BA bigger than AB. Note: uppercase letters have different ASCII. This note correctly points out, and I mentioned before, uppercase letters have different ASCII code than lowercase letters, which means the comparison between the letters in Python is case sensitive. Now let's go on to branching. Branching allows us to run different statements for different inputs. It is helpful to think of an if statement as a locked room. If the statement is true, we can enter the room and your program will run some predefined tasks. But if the statement is false, the program will ignore the task. For example, consider the blue rectangle representing the AC/DC concert. If the individual is older than 18, they can enter the AC/DC concert. If they are younger, 18 or younger, they cannot enter the concert. We can use the condition statements learned before as the conditions that need to be checked in the if statement. The syntax is simple, is as simple as if condition statement, and then followed by if, then a condition statement followed by a colon, which contains a word if, any condition statement, and a colon at the end. Start your task with tasks which need to be executed under this condition in a new line with an indent, as shown here. We can use the condition statements learned before as the conditions that need to be checked in the if statement. The syntax is simple. The lines of code after the colon and with an indent will only be executed when the if statement is true. The task will end when the line of code does not contain the indent. In the case below, the code print you can enter is executed only if the variable age is greater than 18. Is a true case because this line of code has the indent. However, the execution of print move on will not be influenced by the if statement. So let's see what they've done. They are giving an if statement example. They're defining the age as 19. And there's another option for us. If it's 18, what happens then? So expression that can be true and false. If age is greater than 18, so we've given an indent here and we have the expression that is run if the condition is true. So since the age is 19, this condition will be true, so we will print you can enter. The statement after the if statement will run regardless if the condition is true or false. So this will say print move on. So this will say you can enter and then move on. If I change it, it will say move on. I'll just comment this for the sake of people. The reason why I didn't comment it is because also to explain that once you define a variable, if you define it again down below, the last definition takes precedence, and that's where the value will be. So that's the one thing I wanted to mention there as well. So it'll just give us move on. We change the age variable. It is helpful to see the following diagram to illustrate the process. On the left side, we see what happens when the condition is true, and the person enters the AC/DC concert representing the code. Regardless, let's run the else statement. Age 18. If age is greater than 18, print you can enter. Else, print go see Meatloaf. Print move on. So at age 18, we'll see get go see Meatloaf and then move on. Then if we convert this to a comment and uncomment this, yeah, can't have a space there. So then we get you can enter. If you're at 19, you can enter and then move on. So there's that. Now the process is demonstrated below. Now you can take a look at the picture over here. It has been, or you can go back and scroll back and learn more. The elif statement, short for else if, allows us to check additional conditions if the condition statements before it are false. The condition for the elif statement is, if the condition for the elif statement is true, the alternate expression will be run. Consider the concert example, where if the individual is 18, they'll go to Pink Floyd concert instead of attending AC/DC or Meatloaf concert. A person that is 18 years of age enters the area. As they are not older than 18, they cannot see AC/DC, but since they are 18, they can attend Pink Floyd. After seeing Pink Floyd, they can move on. The syntax for the elif statement is similar in that we merely change the if in the if statement to elif. So age is, we define the age as 18. If age is greater than 18, you print you can enter. Elif is age equals to 18, you go see Pink Floyd. Else, go see Meatloaf, move on. So there's three combinations. So 18 gives us go see Pink Floyd, move on. 19 would give us 19 would give us what's happening? 19 would give us you can enter. We can go see AC/DC, and then we get move on. If we do a 17, 17. It's 17. Go see Meatloaf, move on. Then 18, we'd get Pink Floyd. Yeah, then move on. So looking at the following code, the condition statement is album year is 1983, album year is 1970. If album year is greater than 1980, print album year is greater than 1980. So let's just comment this part out, and then it'll print do something regardless. So album is greater than 1980 because we have set it at 1983. If we delete this, and so this will just print do something because this is false. Notice that the code in the above indented block will only be executed if the results of the condition are true. As before, we can add an else block to the if block. The code in the else block will only be executed if the result of the if block is false. So if condition do something else, do something else. If the condition in the if statement is false, the statement after the else block will be executed. This is demonstrated in this figure. Let's go through this example. So condition statement example. Album year is 1983. If album is greater than 1980, print album is greater than 1980, else print less than 1980. So here we go. It's going to be greater than 1980, do something, and then let's so less than 1980, do something. Sometimes you want to check more than one condition at once. For example, you might want to check if one condition and another condition are both true. Logical operators allow you to combine or modify conditions and or not. These operators are summarized for two variables using the following truth tables. So if there is A and B, as long as both are not true, everything else is false. Only when both are true is it true. A or B, either one of them is true, you get true, else only if both are false do you get false. The AND statement is only true when both conditions are true, and the OR statement is true if one condition or both are true. The NOT statement outputs the opposite truth value. So when you give false to the NOT statement, you get a true. You give a true to the NOT statement, you get a false. Let's see how to determine if an album was released after 1979. 1979 is not included, and before 1990, 1990 is also not included. The time periods between 1980 and 89 satisfy this condition. This is demonstrated in the figure below. The green on the lines A and B represent where the statement is true. The green on the line C represents where both conditions are true and corresponds where the green region overlap. So 1979, released after 1979, so 1980 onwards. Before 1990, 1989. So, conditional statement example. Album year 1980. So if album year is greater than 1979 and album year is less than 1990, print album year was in between 1980 and 1989. Otherwise, just print like a line, like an empty line and no characters, and then do stuff. So we will get, we'll get print this album, then no line, and then do stuff. So that's what we got. And then if we do a 78, it won't, just do these two. Okay, and then 84 would also work. So okay, determine if an album was released before 1980, 79 and earlier, or after 1989, 190 or an OR statement can be used. Periods before 1980, 79 and earlier, or after 1989, 1990 and onwards satisfy this condition. This is demonstrated in the following figure. The block of code to perform this check is given by this condition statement example, where album year is 1990. If album year is less than 1980 or greater than 1989, album was not made in 1980s. Else, the album was made in the 1980s. So album was not made in 1980s because this is 1990, just after. The not statement checks if the statement is false. Album equals 1983. If not, album equals 1984. Print album is not 1984, which it will. Album is not 1984. So, write an if statement to determine if an album has a rating greater than 8. write an if statement to determine if an album is if okay, so let's see. Yeah, this album is amazing. If else statement that performs the following: if the rating is larger than 8, print. If rating is greater than 8, print. This album is amazing. Correct. If write an if statement to determine if an album came out before. Okay, this is done. Okay, let's do the quiz. What is the outcome of the following? 1 equals 2 false. What is the output of the following segment code? I equals 6. I is less than 5 false. True or false? The equality operator is case sensitive. In the following code segment. False. Oh, it's true. So true or false? The equality operator is case this. Although this condition is false, this statement is true. The statement. The question is this equal to each other? No, because it is case sensitive. So true or false? The equality operator is case sensitive. True. Which of the following best describes the purpose of elif statement in a conditional structure? It defines a condition in case the preceding. Okay. Expect what? How? How many questions are there? 4? And I missed one of them. Try again, continue. Let's see, where did I mess up? What is the outcome of the following? False. Yeah. I'm gonna check because I'm like, what the fuck? What is the output of the following segment of code? I is less than 5. False. Syntax error can't send literal. Because it was 1 equals fuck, syntax error. You're correct.
In this video, we will cover loops, in particular for loops and while loops. We will use many visual examples in this video. See the labs for examples with data. Before we talk about loops, let's go over the range function. The range function outputs an ordered sequence as a list I. If the input is a positive integer, the output is a sequence. The sequence contains the same number of elements as the input, but starts at 0. For example, if the input is 3, the output is the sequence 0, 1, 2.
If the range function has 2 inputs, where the first input is smaller than the second input, the output is a sequence that starts at the first input.
Then the sequence iterates up to, but not including the second number. For the input 10 and 15, we get the following sequence. See the labs for more capabilities of the range function. Please note, if you use Python 3, the range function will not generate a list explicitly like in Python 2. In this section, we will cover for loops. We will focus on lists, but many of the procedures can be used on tuples. Loops perform a task over and over. Consider the group of colored squares. Let's say we would like to replace each colored square with a white square. Let's give each square a number to make things a little easier, and refer to all the group of squares as squares. If we wanted to tell someone to replace square 0 with a white square, we would say equals replace square 0 with a white square. Or we can say for square 0 in squares, square 0 equals white square. Similarly, for the next square, we can say for square 1 in squares, square 1 equals white square. For the next square, we can say for square 2 in squares, square 2 equals white square. We repeat the process for each square. The only thing that changes is the index of the square we are referring to. If we are going to perform a similar task over and over, consider the group of colored squares. Let's say we would like to replace each colored square with a white square. Let's give each square a number to make things a little easier, and refer to all the group of squares as squares. If we wanted to tell someone to replace square 0 with a white square, we would say equals replace square 0 with a white square. Or we can say for square 0 in squares, square 0 equals white square. Similarly, for the next square, we can say for square 1 in squares, square 1 equals white square. For the next square, we can say for square 2 in squares, square 2 equals white square. We repeat the process for each square. The only thing that changes is the index of the square we are referring to. If we are going to perform a similar task in Python, we cannot use actual squares. So let's use a list to represent the boxes. Each element in the list is a string representing the color. We want to change the name of the color in each element to white. Each element in the list has the following index. This is a syntax to perform a loop in Python. Notice the indent. The range function generates a list. The code will simply repeat everything in the indent 5 times. If you were to change the value to 6, it would do it 6 times. However, the value of I is incremented by 1 each time. In this segment, we change the ith element of the list to the string white. The value of I is set to 0. Each iteration of the loop starts at the beginning of the indent. We then run everything in the indent. The first element in the list is set to white. We then go to the start of the indent. We progress down each line. When we reach the line to change the value of the list, we set the value of index 1 to white. The value of I increases by 1. We repeat the process for index 2. The process continues for the next index until we have reached the final element. We can also iterate through a list or tuple directly in Python. We do not even need to use indices. Here is the list squares. Each iteration of the list we pass one element of the list squares to the variable square. Let's display the value of the variable square on this section. For the first iteration, the value of square is red. We then start the second iteration. For the second iteration, the value of square is yellow. We then start the third iteration. For the final iteration, the value of square is green. A useful function for iterating data is enumerate. It can be used to obtain the index and the element in the list. Let's use the box analysis of the following index. This is a syntax to perform a loop in Python. Notice the indent. The range function generates a list. The code will simply repeat everything in the indent 5 times. If you were to change the value to 6, it would do it 6 times. However, the value of I is incremented by 1 each time. In this segment, we change the ith element of the list to the string white. The value of I is set to 0. Each iteration of the loop starts at the beginning of the indent. We then run everything in the indent. The first element in the list is set to white. We then go to the start of the indent. We progress down each line. When we reach the line to change the value of the list, we set the value of index 1 to white. The value of I increases by 1. We repeat the process for index 2. The process continues for the next index until we have reached the final element. We can also iterate through a list or tuple directly in Python. We do not even need to use indices. Here is the list squares. Each iteration of the list we pass one element of the list squares to the variable square. Let's display the value of the variable square on this section. For the first iteration, the value of square is red. We then start the second iteration. For the second iteration, the value of square is yellow. We then start the third iteration. For the final iteration, the value of square is green. A useful function for iterating data is enumerate. It can be used to obtain the index and the element in the list. Let's use the box analogy with the numbers representing the index of each square. This is the syntax to iterate through a list and provide the index of each element. We use the list squares and use the names of the colors to represent the colored squares. The argument of the function enumerate is the list, in this case squares. The variable I is the index, and the variable square is the corresponding element in the list. Let's use the left part of the screen to display the different values of the variable square, and I for the various iterations of the loop. For the first iteration, the value of the variable is red, corresponding to the 0th index, and the value for I is 0. For the second iteration, the value of the variable square is yellow, and the value of I corresponds to its index, i.e. 1. We repeat the process for the last index. While loops are similar to for loops, but instead of executing a statement a set number of times, a while loop will only run if a condition is met. Let's say we would like to copy all the orange squares from the list squares to the list new squares, but we would like to stop if we encounter a non-orange square. We don't know the value of the squares beforehand. We would simply continue the process while the square is orange, or see if the square equals orange. If not, we would stop. For the first example, we would check if the square was orange. It satisfies the condition, so we would copy the square. We repeat the process for the second square. The condition is met, so we copy the square. In the next iteration, we encounter a purple square. The condition is not met, so we stop the process. This is essentially what a while loop does. Let's use the figure on the left to while loops are similar to for loops, but instead of executing a statement a set number of times, a while loop will only run if a condition is met. Let's say we would like to copy all the orange squares from the list squares to the list new squares, but we would like to stop if we encounter a non-orange square. We don't know the value of the squares beforehand. We would simply continue the process while the square is orange, or see if the square equals orange. If not, we would stop. For the first example, we would check if the square was orange. It satisfies the condition, so we would copy the square. We repeat the process for the second square. The condition is met, so we copy the square. In the next iteration, we encounter a purple square. The condition is not met, so we stop the process. This is essentially what a while loop does. Let's use the figure on the left to represent the code. We will use a list with the names of the color to represent the different squares. We create an empty list of new squares. In reality, the list is of indeterminate size. We start the index at 0. The while statement will repeatedly execute the statements within the indent until the condition inside the bracket is false. We append the value of the first element of the list squares to the list new squares. We increase the value of I by 1. We append the value of the second element of the list squares to the list new squares. We increment the value of I. Now the value in the array squares is purple. Therefore, the condition for the while statement is false, and we exit the loop. Check out the labs for more examples of loop, many with real data.
Alright, so we're gonna do this exercise on loops in Python, and there we go. So loops. Let's look at the range function. Sometimes you might want to repeat a given operation many times. Repeated executions like this are performed by loops. We look at two types of loops: for loops and while loops. For loops are while loops are never-ending loops, while for loops usually end. No, that's not necessarily true. Before we discuss loops, let's discuss the range object. It is helpful to think of the range object as an ordered list. For now, let's look at the simplest case. If you would like to generate an object that contains elements ordered from 0 to 2, we simply use the command range 3 or range 0, 3. So we get range 0, 3. We get an object called range. Range object, okay. The for loop enables you. So what is the for loop for? What is for loop? What for loop enables you to execute a code block multiple times. For example, while the statement is true, right? Yeah. Would use this. You dates 1982, 1980, 1973. N equals length of dates for I in range n. Print dates I. The code in the indent is executed n number of times. Each time the value of I is increased by 1 for every execution. The statement executed is to print the value at index I as shown here.